This is the second video in how to go ahead and start working with Grasshopper as a fabrication tool. And in this case, we're going to make contour map out of the object here on the left. If you haven't watched the first video yet, you're going to want to go ahead and do that. That's kind of more of an intro video. It talks about how we went ahead and use the contour operation within Rhino to be able to generate the actual map. We're going to do something similar, but we're going to make this kind of more dynamic and allow us to more quickly lay everything out and have everything labeled opposed to having to do that manually. So again, you're going to make sure you have this file downloaded from the Carmen site underneath the Assignment04 header. And we're going to go ahead and start with a brand new Grasshopper definition here on the left. So again, the way we did this in Rhino was to start by making a bounding box around the object. And we're going to do something very similar here in the Grasshopper environment. So the first thing we want to do is bring this object from the Rhino environment into the Grasshopper panel over here on the far right. We did that in the last video with the Rhino point, and we used a parameters geometry point container. This is obviously not a point, so we have to use a slightly different container. We're not going to be anywhere here in the middle, which deals with circles and polylines, things like that, curves. We're going to be here kind of in the third section down. Now, what type of object is this? Well, the most kind of broad type of object is what's considered a B-rep, or a boundary representation. That is simply any sort of three-dimensional geometry, or actually it can be two-dimensional geometry, anything that has physical geometry that has finite boundaries to it. It cannot be something like a vector or a plane. It has to have actual boundaries to the object. So we're going to go ahead and click that. And you'll see it says B-rep right here in the preview. I'm going to go ahead and right click, set one B-rep, and click on my Rhino geometry. And you'll see now that it gets this kind of red, almost camouflage. All that means is there's two objects coexisting. One of them is the actual Rhino geometry, and the other is the Grasshopper geometry that are kind of one on top of the other. You can always hide the Rhino geometry, and you can hide the Grasshopper geometry as well by simply right-clicking and disabling the preview. It goes to a dark gray here, and you'll see you can no longer see it here in the Rhino screen. I'm going to undo that by right-clicking and setting the preview again, and you'll see I get a light gray, and I can actually see it being selected over here on the right. The other thing I'm going to do is I'm going to change this label. And you can do this with all the components, but you want to be very careful what you do because you don't want to lose the name or something about the name of the component. You don't want, for example, I could drop this point component in here, and these are two very different components. One's containing a boundary rep, or a B-rep. The other is containing a zero-dimensional point. You don't want to mistake these by giving them titles that might be similar. So what I'm going to do is I'm going to go ahead and relabel this. To do that, I'm going to simply right-click on it, and in the word B-rep up here, I'm going to say this is my my surface, my base surface. Okay, I could call it my base object. Actually, that's a little bit better because that starts to say that it's more of a three-dimensional object opposed to a two-dimensional surface. So I don't need this point component. I was just going to bring that in for reference. So there's my base object. Now the first thing I need to do is be able to make a bounding box around this thing. To do that, I'm going to go ahead and go to my surfaces. We're going to go to primitive, and bounding box is an option in here. Now, not all the components in Rhino or operations in Rhino have corresponding Grasshopper components, but many of them do. And this happens to be one that does. Now there are two inputs, and you don't necessarily need to always run something in an input, and some inputs inherently have values stored in them. So the two inputs it's asking for is the actual geometry you want to contain and the plane that you want to orient the resulting bounding box on. Okay. In this case, the plane is already set for the XY plane, which is exactly what I want to orient the bounding box on, is the XY plane, in this case the construction plane. The only thing I need to do is wire in the original geometry into the contain geometry as the input, and there we go. I get two outputs. One of them is the aligned bounding box relative to the world coordinates, and the second is the one aligned oriented to the plane here that we fed in. By default, these two things are actually the same thing because in this case the world coordinate is the XY plane, so we get the two outputs here are actually identical bounding boxes. We only need to deal with one of them. We're going to just focus on this top one just to make life a little bit easier. So there's our bounding box. Now you remember the next thing we did was duplicate edge. To duplicate the edge, we're not actually there is no duplicate edge command, but in turn what there are is different, underneath the surface tab, analysis, different ways to extract edges. And you'll see you have brep edges or brep wireframe, deconstruct things, all those are options. So let's go ahead and use just the brep edges. And again, remember, brep is really generic for any sort of three-dimensional object that has finite boundaries to it, boundary representation. We're going to go ahead and wire that into the brep input. And you'll see what you get is any naked edges. A naked edge is an edge that isn't joined to an edge of a surface that's not joined to another edge of a surface. Interior edges, here we have 12 line-like curves. And then the non-manifolds. The only thing we're really interested in are any of these interior edges. Now you don't have to do this. I'm going to do this just so we can see. I'm going to go to parameters, and I also use panel tools not only as ways of entering information, but also looking at our information. So here we get 12 line-like curves in here, and those correspond to the 12 edges that make this up. There's 4 edges around the bottom, 4 edges are along the top, and 4 vertical edges in the corners here. Each of these numbers on the left are called an index number. And it's a way to reference these, because all of these are considered line-like curve. You have to be able to say, I want the 4th line-like curve versus the 7th line-like curve versus the 12th. You use these line numbers on the left, which are called index numbers. You'll notice he always started counting at 0, and it always has 1 less than the total number because you've started counting at 0. We want one of these verticals. So we have to somehow figure out which of these line-like curves is one of the verticals. To be able to pull out one of these, because right now all 12 of these are coming as outputs. We don't want all 12 of them. We only want one, and one very specific one, which is one of the verticals. To go ahead and isolate one of those, this is a list of information. We want to list one of these items that are in here. So again, we're going to go to sets, because sets deal with lists of information. Go to the list panel. And on the left here, we're going to use the list item component. So there it is. What this is saying is, okay, give me a list of things to sort through. Give me an index item number, one of these numbers on the left here, and I will spit out the resulting object that exists at that index number. The W here is a wrap, meaning if I run out of numbers and I say I give it the number 12, do I want to start, once I count to 11, do I want to start the 12th one is at the top again? That's just a simple true-false operation. Right now it's set for true. It doesn't matter in this scenario because we're only going to give it one value of 0 through 11. So again, we never want to go through a panel tool. We could easily wire it something like this and start running this list into here. But panel tools have a little bit of an error to them. The software hasn't been fully developed yet, and sometimes things get hung up in panel tools. So I only like to use them either as inputs or outputs. I never like to go through them. So I'm going to wire the output directly into the list item. You'll see now you can actually wire multiple outputs and use them in different ways. So the same list that we are seeing here is the same list going into the L input here. Now, which of these do I want? Well, I can tell you the way that Rhino makes geometry is that the 4 on the bottom edges are items 0 through 3. The 4 on the top are items 4 through 7. And all the verticals are items 8, 9, 10, or 11. So if I want one of these verticals, regardless of which one I want, I'm going to want either item 8, 9, 10, or 11. So I'm going to go ahead and just start by using the item number 8. So again, anytime I want to input a single entity, a single number, I'm going to use a panel tool. So the same way you used that as for the radius in the last video, we're going to go ahead and use it here. In this case, I'm going to use the value of 8. Again, do not hit enter, do not hit spacebar. You're going to have an error if you do. If for whatever reason your list item component goes red, it's probably because you either hit spacebar or enter after the number from the panel tool. Remember, red means something's wrong. You've given it the wrong type of information. In this case, by putting an enter, you've actually given it 2 entries, but the second entry is blank. Here, we just want to make sure that that cursor is flashing directly after the 8. Click off of it. You can always minimize this if you want. And now coming out of here, you'll see you only get one item. It's been moved to the top of the list, and it's again a line-like curve. If I simply click on this list item, you can see that one of my things has turned green. You can just barely see that there. If you want to see it better, turn off some of this old stuff, meaning right click on the body of the component where the black bar is, and disable the preview. Right click on the body, disable the preview, and there you go. Now you can see that red vertical line. If I select the actual item component, it turns to green. That's the vertical line. Okay. Remember, that was our second operation when we went ahead and did that in Rhino. Now, if you did this in Rhino again, you would simply type in contour and start drawing a perpendicular. But if you did this manually, what you would do is you'd start making a bunch of horizontal surfaces or horizontal planes, either one, and then intersecting the horizontal planes with this base geometry. Well, we need to do something similar. We need to make a whole series of horizontal planes or horizontal surfaces at a series of points that are all spaced out based off of our material thickness. And in this case, we used 1/16 of an inch. Just a quick side note, the difference between a surface and a plane. A surface has finite boundaries to it, okay? So a surface has absolute edges, so I can go ahead and draw a surface like so, meaning that it has a finite edge to where that surface ends. A plane, much like a construction plane, goes on forever. So I like to use planes because you know that they intersect the whole object, okay? So what I need to do is I need to take this vertical line, divide it by a certain distance in between each set of curves, okay? Those points that I divide it by, those points are going to act as plane locations. So we're going to take this line like curve. I'm going to just delete this panel for a moment, but take the line like curve coming out of this list item, go to my curve, divisions, and divide distance. Divide by curve with a preset distance between the points. Okay, so I'm going to take that curve, that becomes the item coming out of the list. So the curve coming out of the list is going to go into that distance component. And now it's asking the distance I want between the points. What I can do here is either run a panel tool or a number slider, either one. I'm going to use a number slider in this case, and run that into my distance. This becomes essentially my material thickness. So the distance you see here between each of these points now corresponds to the number that this slider is. So the larger that number is, the fewer points you see. The smaller that number is, the more points you see. Obviously, we can't divide by 0, so we're going to want to adjust this slightly. Two things I'm going to do. I'm going to relabel this, and I'm also going to adjust what the minimum value is, because you'll see when we go to 0, it throws an error or makes our component red. So I'm going to make sure that the minimum value is, say, 0.001. I'm going to double click on the word distance, make sure that this minimum value is 001. I'm also going to rename it. So here on the top, instead of it just being distance, this distance actually is the material thickness. So I'm going to call that my material thickness slider. So now I know as I adjust this, this corresponds to my material thickness. If you want to set it to a very particular value, in this case we're going to set to 1/16 of an inch, which is 0.0625. I'm going to double click and type in 0.0625 and hit the green checkbox there. You'll see it rounds up to 0.3 because we only have that many decimal places, but there you go. There are all the points at which we need to make surfaces or planes to intersect with our original object. Okay. To do that, what we want to do is we can make XY planes, planes that are on the kind of parallel to the construction plane here. If we go to Vector and Plane tab, you'll see you have a bunch of planes in the top here, and we want to use the XY plane. And we want to put an XY plane with its origin at each of these point locations. So you'll see when I go ahead and draw it, there now are a whole stack of horizontal planes. And even though the planes have these edges, you have to understand a plane goes on forever. We can't represent it forever the same way we can't represent this construction plane forever, because that grid would just go on and on and on. They ended at a certain point, but we know it's a construction plane that goes on forever. We know that these grids here coming from this XY plane go on forever as well. There we go. Now we've created a bunch of planes, and the last thing we need to do is intersect these planes with this geometry. And when you intersect a plane with a three-dimensional object, what you get is a closed polyline. So to do that, we're going to go to our intersect tab here. Because we're dealing with planes, which are a mathematical construct, we're going to go to mathematical tab, and we're going to intersect a B-rep with a plane, or in this case, a series of planes. It's actually called a section component. The label for it is actually section. The B input is asking for the B rep. The B rep we want to give it is the original geometry, or this base object. So we're actually going to wire it to a second input, like so, bypass basically all of this. And we're going to wire the planes that we just made into the P input. Now if I go and hide all this stuff by simply selecting it all, in space, right click, preview off, you'll see now when I deselect, there are all of my planes. And the nice, or my curves, my contour curves. And the nice thing about this is as we adjust my material thickness, though it can be a little bit slow, you can see we can make more or less contours depending on how many we want to generate or what our material thickness wants to be. Again, I'm going to go ahead and set this to 0.0625 and hit select. And there it is. There's our individual contours. Okay. Now we're going to want to do a couple other things. We're going to want to lay these out on the XY. All we've done is stack them. We're actually no better off than just doing the contour map at this point. And I guess the only better off part is we can make it more dynamic or adjust it more quickly. But we're going to want to go ahead and lay these all out on the XY plane. To get ready for that, what I want to do is explain a little bit about how we work through this. This is kind of one complete idea. Think of this like you wrote a paper. All of this together is one paragraph in your paper. Several of these strung together, all these components are like words, and then you made sentences. And now this is one complete idea, so we've completed a paragraph. What I want to do is I want to use a panel tool to just divide up my paragraph. So I'm just going to go ahead and drop in a panel tool. I might call this step 1. Okay. And down here you might describe a little bit of what you did. So what we did was we created a bounding box around the original geometry. We then extracted one vertical edge. We divide that edge by our material thickness. Create XY planes at these points. And lastly, intersect our object with these planes to create contour lines, like so. So that little paragraph talks about what we're going to do, and you're going to want to do this for every single step. So I'm going to go ahead and just start a next paragraph down below here, and I'm going to call this step 2. Now we're not going to talk about it just yet. We'll come back and fill this in a moment, but we want to use this just as a way of dividing up the paragraph. Okay, so the next video we're going to go ahead and pick up from here. If you had any questions, go back and rewatch this and kind of get your way through it so that you're at least at this point. Be sure that you've turned off all these components. Remember, all you do is you just select them, drag select, right click in space. Don't click on a component, click in space and turn the preview off. The only preview you want to leave on is the actual section component at the very end, because that shows you all your most recent geometry. All right, we'll see you in the next video.